Hello, and thanks for being here today. So I'm going to talk a bit, like a lot, about GraphQL and our journey at my company, where we went from the REST API to the GraphQL one. So a little bit of introduction. My name is Julien Salvi. I'm the lead Android engineer at Aircall. And on the side, I'm an Android GD, part of the Paris Android user group. And on the fun side, I'm listening some punk rock music and drinking IPA beers. So, and I'm still sharing some tech stuff on Twitter, so if you want to follow. So, what's going on today? I'll be giving a little of introduction and context. So why GraphQL, why we migrated from REST to GraphQL at Aircall. Then a short introduction, how to deal with Apollo Kotlin and GraphQL and how to set up the thing on your code base. And then it's going to be a return of experience of the migration itself inside our Android application. So let's get started. Little bit of introduction and context. So at first, we're going to see question, what's GraphQL? So GraphQL is an open source query language and runtime that provides an efficient and flexible approach to fetch data and manipulate it. Developed by Facebook and then was open source. So the 3 key points of GraphQL, let's say. Number 1 is efficient data retrieval. So we can fetch data, the data we want, and the exact data that we want compared to the REST API, and potentially eliminating overfetching and underfetching data. Simple endpoint simplicity. So that's one of the main points. The GraphQL simplified the interaction with a single endpoint. So no need to implement many routes and to fetch your data. One simple endpoint, and then all the query and mutation will do the work. So this will reduce the round trips and the streamlining communication. And the third main point is the strong typing and introspection. So this is the key advantage. With the GraphQL schema, you have a strong typing inside, so you know what type of data it is, nullable or not. So you have a strong contract with your backend from your client side. But you might wonder, so this is what is GraphQL? So why we went for GraphQL at Aircall? So 4 main points here. Because of the scalability of our REST API, we wanted to break the huge monolith we have into microservices. The REST APIs was not modular enough and has some scaling issue. Second point, we wanted to have a serverless alternative. Spoiler alert to our tech stack behind on the backend side is mainly AWS. So we wanted to take advantage of the serverless implementation. So that was one of the 4 main points. Another point was the efficiency of the data aggregation. So the need to have a very good communication between microservices and a point of data aggregation. And also, while migrating, we wanted to have a minimum description while migrating from our REST API and GraphQL API. So that's why we went from a REST to a GraphQL API. So with that, now I'm going to give you all the key points why we went for GraphQL. As I say, data efficiency. So to request what we want, data aggregation. So we can fetch, for example, multiple resources at the same time with our queries. Real-time communication was also a key point. Thanks to the GraphQL subscription, we can open kind of a WebSocket to have some data that we are listening on the client side. We wanted to have a federated API for GraphQL, so multiple microservices that we push and update the GraphQL schema. This will improve like the scalability of our system. The strong typing to have like a very strong contract with our backend and a very strong data validation. And also, one of the key points of GraphQL might reduce the latency because GraphQL support batching requests, can like aggregate multiple data at the same time, so it will improve overall our performances on the backend side. So how we use it on at Aircall. So the tech under the hood mainly relies on AWS AppSync. That's on the backend side. Our infra relies a lot on AWS, so the backend teams went with the AppSync implementation. Why AppSync? Because for them, it offers many capabilities like feed clearing, real-time, and scalability. And it has also very nice integration with our tech stack, Elasticsearch, DynamoDB, and AWS Cognito, which is our authentication stack. So that's why on the backend side, they went for AWS AppSync. But on the Android side, we went with Apollo. So know the SDK about AppSync. You'll see why in the next slide. But for us, it was like very straightforward to choose Apollo. Why? Because it has a great interoperability with our Kotlin code base. Apollo, Kotlin, 100% Kotlin. The model generation are in Kotlin. We have the data classes in Yen. Apollo is multi-platform, one also key advantage. You can use like queries, mutation, and subscription, all good. It has a great caching system. It has improved since the first version. It has a AppSync and the GraphQL, the WebSocket support. So even if we are not using the AppSync SDK on our side, Apollo supports the AppSync communication. And one of the main strengths of Apollo, it has a great community and great maintainers. So like a bit of overview of what we are today. So we introduced like GraphQL at our company 2020, end of 21, being our first feature with that. Then all new features were built with GraphQL. We are currently in the move of the big monolith transition and moving all of our REST API into the GraphQL one. And now the clients are migrating to the new GraphQL endpoints. So now we have set up like the big picture of why we went for GraphQL. Let's see how we brought the GraphQL API inside our Android app with Apollo. OK, now a bit of like introduction on how to set up Apollo Kotlin within your code base. So it's pretty straightforward to set up Apollo Kotlin in your Android project. You're going to see how we're going to deal with the big GraphQL schema, which will be our source of truth. Then we'll see how we can like deal with queries, mutation, subscription. Queries, if you want like the parallel in REST API, it's a get. Mutation will be for like the post, patch, delete, and so on. And subscription is more like a WebSocket universe. So, and then our Apollo client, you'll see, is going to be living with inside our code base with our retrofit client. And the two won't collide and works very well side to side. OK, so when you want to add Apollo to your Android app, you're going to add the Apollo 3 plugin, then add the dependencies, and then you will set up like inside your module or inside your general app package the service and the package name you want for the model generation. So as you want, for us it was com.aircall, but it can be whatever you want. So then you're going to deal with your schema. So that a schema might look like this. So this is a sample of what might it looks. So you're going to deal with your backend teams and say, OK, and so I'm going to download the schema. And so to do it, you can use like a Gradle command with an Apollo command as well. So the download Apollo schema. So you're going to put the endpoint, and then you're going to download inside your module and inside the folder GraphQL the GraphQL schema. It could be a .graphqls or a schema.json. Up to you. On our side, we are using a schema.json. So now you have downloaded your schema. You're going to put and write your first queries or mutations. So inside your GraphQL folder, where the schema is located, you're going to create a new, like let's say, user.graphql file. And inside that, you're going to write your first query. So here, for example, it's to get the working hours of our agent. So we're going to put the user ID, and then we're going to query the agent with its business hour. So OK, we want the business hour object inside and want the slot object, which contains days from and to, which are dates. And days are an array of integer, I think. And, for example, the time zone. So with that, I'm defining what I want to get from the agent. The agent has like many other objects, but here I'm just targeting the business hours. First pro tip, when using like Apollo and stuff like this on Android Studio, you can take advantage of the GraphQL plugin made by Jim Kenmeyer to have the auto-completion and deep link support when you're writing your queries. So as a tiny example, so for example, this is our code base. We have our working hours here. So we have our queries and mutation. And with that, we can like have a deep link with our object that is located inside our schema. So we can actually know what to get. For example, get agent, if you want to know more, control space, OK, I have last name, first name, picture URL, stuff like this. You know what to query and what's available like in the query or in the mutation object. So that's a very good thing, like to have some auto-completion when you want like to search the object you want to get or to update. Not exactly the thing. OK, that's better. OK, so now we can write also a mutation, like to, for example, here update the read count of a conversation. Pretty simple. We call the read conversation object, pass the input, and then the result will be a conversation ID. Pretty simple. And for the subscription as well, we use service subscription, the name of your function, and then you call the subscription object you want to listen. So now you're like building all your GraphQL queries, mutation, subscription. When you build your project, all like Kotlin code will be generated automatically. And now you can like build your Apollo client in order like to really query or mutate your data. So pretty simple. It goes with a builder. So you're going to put your server URL, WebSocket URL if you want like to implement some subscriptions. And also you can pass an OK HTTP client in order like to add some interceptor if you want to manage some logging or authentication, stuff like this. So it works very well with OK HTTP. And with that, now you are able inside your code base to manage your query and mutation. So if I want like to get like the query regarding the working hours I just made before, I'm gonna put the class that has been generated, the get agent working hours query, and this query gonna be passed to the Apollo client. And then the .execute will call this like coroutine friendly stuff. And then we're gonna like get our data, deal with our data, our business hour, all gonna be typed, and we know what we're gonna get in the end. Okay, that's pretty much it. Like now you are all set to like using your Android app with GraphQL and Apollo, and you are good to go to query your data. So that was our first step initially when we first implemented the GraphQL API on Android to build our messaging feature. So it was like almost 3 years ago, but it has not been like an easy way to get like everything working pretty good at the same in the end. So let's see the good, the bad, what we learn from migrating from our REST API to GraphQL. So first thing we loved, and Apollo loves Kotlin, so we loved Apollo. Why? Because Apollo is 100% built with Kotlin, so it's the best interoperability when you have a Kotlin code base. It has a great support for coroutines and Kotlin flows. If you are using coroutines, it's pretty easy to use and query your data. Same if you have some reactive programming with Kotlin flows, it has like you can use flows within your query. And for sure, it generates Kotlin code from the schema, so you're gonna deal with data classes, and even the queries and mutation objects are data classes, so you know how things is working, and it has great Kotlin code generation. So for the Kotlin support, for example, like the code I just showed before, so you're gonna query the query you want with the Apollo client and call the .execute, which will return like a suspend function with the data associated. So no need like to implement callbacks and so on. So you get the data straight to the point. And for the Kotlin flow support, for example, we are using it mainly for our subscriptions. Here, like to have a node-read message counter. So we get the Apollo client, pass the subscriptions, and then we call it like to flow, and then we can like collect the data each time there is a new one, handle the error if there is any, and even apply like a retry policy on the flow itself. So pretty convenient when you deal with some reactive programming with Kotlin flow. And for the Kotlin code gen, let's have a look at Android Studio. So here, when you build your project on the side, so build folder, you have like the Apollo source that contains all the generated code. So types will contain all the models. Let's say, for example, like availability or even like an agent. So it's going to be a class here for every model and type that will be used by our Apollo client. And all the query and subscription will be generated here. So from for example, our working hours query here, it's going to be generated. So get agent working hour query. From this query, you're going to get a Kotlin class that has been generated by Apollo. And this one will be your main entry point, like to div with the query. So everything is Kotlin, everything is like mostly understandable, and so you always deal with Kotlin code on the end. So now let's see one of the things alerting a bit at the beginning, beware the timeout. We were not like, when building our HTTP client, let's say, okay, we have the one for the REST API. Why not using it for the GraphQL API? In the end, it's the same backend. Nah, no. If your REST API is using a timeout, for example, like we put it like 15 seconds, don't use the same one for your GraphQL API. On the backend side, it might, in the end, get fetch the data that fetch also the REST API, but the solving on the backend side might take sometimes a bit longer. Microservice communication sometimes not optimized. So think with your backend team and other clients team to identify the best timeout to pass to your GraphQL client. Might be less, might be more, but please don't technically use the same one from your REST API. And if you are using HTTP, don't reuse the same client for your REST and GraphQL API for sure. So another thing, use the lazy loading if it's needed. Lazy loading, like from a Dagger Hill perspective. For example, when we first introduced GraphQL inside our code base, we actually use it for messaging, which were like under a feature flag. So not all clients had like the opportunity to have the messaging feature. So it was just for a part of our clients, and taking advantage of the lazy loading with Dagger Hill, you won't like load the Apollo client for users that don't need it. So it's a gain of like a bit of performance memory usage here. People who don't have the messaging feature and don't use actually the GraphQL API don't need like to have the whole Apollo client loaded on their application. So by that, using the lazy, then when you are calling the Apollo client, in order like to get the client, you just call the get method, and then you can access the real Apollo client. So by that, you can defer the resource loading and refer the loading of your Apollo client. One of our also other key takeaways is the monitoring. So it's pretty easy and almost the same as monitoring the REST API. For sure, always monitor your request, even if it's on develop or on production. You can take advantage as the Apollo client accepts OKHTTP clients. Take advantage of the OKHTTP interceptor to monitor your queries and mutation. One tool we really like at Aircall is using the checker in our development mode to monitor our requests when we are testing the application. And if you want like to know the latest update, check the talk of Nicolas Corti. Don't remember if it's today, tomorrow, or Friday. But he's going to introduce checker the latest one, the 4.0. And if you want like, to monitor your request, even REST API or GraphQL, it's going to be an interesting one. And especially he added more feature on the GraphQL monitoring. So if I want to showcase a bit the monitoring, so for example, this is my app, and okay, and here we have our checker notification. So here you have like all the requests made by our application. So here in develop, so I can click on it, see the payload, what has been passed, and so on. check the response, like an overview of the request. So you can see, okay, the time is like too long, maybe there was some network issue, or the backend took many days to compute the response. So it's very interesting, like to use and monitor the data. You can search for like maybe search for conversation up, and it highlights the data you want to look at. So pretty interesting tool, like to monitor like all the requests you have inside your application. To monitor it, so for using Checker, you create a Checker collector, passing the context, if you want to show the notification or not, and the retention of the data. It can go like for a couple hours, days, or week. And then you are building your Checker interceptor that you will be using inside your OK HTTP client. So passing the Checker collector, so all the data setup. If you want to redact some headers, like some authentication headers, bearer, and so on, you can do it. Redact any headers you want. One other thing, like when you want to monitor, always read the response body in case there is some parsing error and stuff like this. Very good, like to use it. And if you want like to create a shortcut directly within your Android app, you can choose like to do it or not, up to you. And then you're going to inject that inside your OK HTTP client, and you're going to be good to go. And the demo was already done. OK, so one other thing we like, but great power comes with great responsibilities. So beware and use nested queries. So nested queries is a very powerful feature coming from GraphQL. So we know GraphQL has many capabilities, but nested queries is a very good one. It's very efficient when you want like to do some data aggregation. So you can get multiple data from different sources at the same time. But when you do that, don't aggregate like many data, and check with your backend teams how things are implemented on the backend side, because the response time might increase a lot if you want like to aggregate the world. It can take forever. So always monitor when you are using some nested queries, and synchronize with your backend teams to find the best solution. That's one of the key takeaways we learned from that. Don't go and use your the schema and do like whatever you want with it. Always monitor and sync with your backend team to find the best query or mutation the optimized way. So, for example, here we have our query to get a list of conversation, and it was pretty efficient. We get the conversations and all the details we want in that, and so on. And we wanted like to add the last message coming from a conversation, like to display it in our list of messaging. So the list of messages was exposed inside the conversation. Say, okay, we're gonna pass the limit on next token. So the limit is gonna be 1. I want to get the last one. Then I wanted like to get the text of the message and the ID, some data. But in the end, using this nested query, we went from like a few milliseconds to almost 10 seconds for getting this data. So it was a huge no in the implementation side. So we sync with the backend side, check with them why it takes so long. So they optimize then the query. In the end, push the new updates on the schema. So we updated the schema, and they exposed like a new object, last message, and they did some optimization on the database side, query side, but that's some backend work. But in the end, we have like a proper way now to get the last message and an optimized query that takes no more than a few milliseconds. So that was like the thing when dealing with nested query. Don't go straight and use everything. Monitor it. Now, I think it was like the most painful part we experiment when using GraphQL, using subscriptions. And it's really not easy, especially when you have like an Apollo client and an AppSync backend. So subscriptions are like long-lasting operation. So you launch it at the launch of your application, and it's an open connection. So mainly a WebSocket, and you listen the data that is sent through this WebSocket. So the data is pushed to the socket, and on the client side, we listen it. Like if you remember, like the slide about subscription, we put a flow and we listen all the updates on it. But keeping the connection alive is not really easy, especially when you need like to authenticate your WebSocket, especially with AppSync. It's not the same as the classic Apollo WebSocket implementation. So things might get a bit more complicated when you are using AppSync. And spoiler alert, we had like to build our own AppSync protocol like to match our authentication stack to handle the token refresh. So it was a bit painful at the beginning. So when you are building and working with WebSocket, so you are building your Apollo client, set the server URL, you build your WebSocket server URL. Here you build that the WebSocket protocol, so you're gonna using the AppSync WebSocket protocol. Build it, and in order like to implement the reopening strategy in case of the WebSocket disconnect and stuff like this, you have like to use the lambda inside your Apollo builder, so WebSocket reopen when, and then with that you're gonna put like the strategy. Okay, when I get Apollo auth exception, I'm gonna try to reopen the socket. Otherwise, if the thing has failed for less than 3 times, I'm trying to reopen it. If it goes above 3, okay, I'm not gonna reopen it, and it's gonna be closed forever, unless I force the reopening of the socket. So, but you might want to know, so why and where does this Apollo auth exception come from, and how is this triggered? So with this, it's actually like at the beginning it was like brain mindfucking. When you have like your OK HTTP authenticator, you inject it inside your auth client, OK client. Every time we have like a new authentication, so we renew the refresh token, or we have a 401 and so on, we have to query on the GraphQL client side the close connection. And close connection, we actually reopen, kind of close and reopen the connection, especially when we pass the Apollo auth exception. So actually, the close connection reopen the connection. It's like a reset of the WebSocket. So at the beginning, we were not aware of that. When we talked with the Apollo maintainer, they said, "Oh yeah, the documentation is not like well defined on that place," and they improve it and even fix some like flow retry policy. So it was like, okay, we have a problem, talk to the maintainers, even open an issue or so on, and they are very active on that. One other thing that came later, we were investigating a socket disconnection issue, again, with the Apollo and the AppSync subscription. And we saw like an open issue on the repository. It was like, okay, it was a feature request to allow changing the server URL real time, because it was just like putting the function and it was set at the beginning. So and say, okay, I think our problem comes from that that feature request. So because when we set the WebSocket server URL, it was a plain function. So when we build our client, it's set and it will never change. So we build our URL, and when we have a new like token, a refresh token for our server URL, AppSync needs the authentication inside the WebSocket server. It's not the same if you are using the Apollo WebSocket, but for AppSync, it requires the authentication inside the WebSocket server URL. So, like at first, it was like, okay, do we want like to restart totally the client when we have a new auth token? No. No, that's not a reliable way, and it's not going to pass successfully the review and stuff like this. So what we thought about, like resetting all the clients, did the trick, but it was not efficient at all. So passing a lambda, we came to that. Passing a lambda will enable like to recall this kind of build URL function, and with that we will be able like to rebuild our new URL with our new auth tokens and so on. So this kind of approach was like a very nice fit for us, and it will solve our connection issue with our WebSocket. So we took a look at the feature. No ongoing development for that, but it was like really needed for us. So we decided like to contribute to the Apollo Kotlin repository. Apollo Kotlin is fully open source, so even the maintainers are very happy to receive lots of contribution, and they are very active on that. If you propose some feature change, within a day or two, you will get back some feedbacks and so on. So as there was no ongoing development on their side, we decided like to go and fix our issue that was a feature request. So on that, so I open for the project and then make our changes, get few back, added the documentation and so on. But it was pretty nice like to contribute to an open source project and fix our issue and issue some other people had with the AppSync subscription. So it was pretty good, and that's one of the benefits of like using Apollo Kotlin. They maintain the library a lot and push a lot of updates quite often. So thankfully, they then merged the feature request and then release it within weeks, I think 2 weeks or so. And then we get a date, and the subscription were working fine, and till then, finger crossed, still working. Okay, one other main thing is error handling. This one, it's a pretty tough one. It's very different from the REST API. Error can be exposed in multiple ways in queries or mutation, or can be accessible directly in the Apollo response from the library, or it can trigger an exception. So almost 3 ways to handle the error. The Apollo response exposes a list of potential errors, so you have to parse it. multiple sources of truth for the error and the error parsing. And it's a bit of pain dealing with the proper error handler. So for now, we didn't find the best approach to do it. We parse sometimes the response, sometimes we check the list of errors returned by the Apollo response, and we handle also the exception from. So 3 ways to implement it, like getting the error that might be contained inside the query when we define the error message. Can be a list of error contains also inside the Apollo response. If I go to Android Studio, so the response here, the Apollo response looks like this. You have the UID of the request, the operation, the data, and a list of error that might be populated by the backend when there is an error. So, 3 ways, and it's not like, for now, we didn't find the best way to handle this kind of errors. So still work in progress, and hopefully in the coming months, we'll have like a reliable solution to parse the error. One other nice thing is the schema automation. We have automated the schema in order like to get the update more frequently on the schema. And when you are working with multiple flavors, this kind of things is quite mandatory if you don't want to spend time updating yourself the schema. So let's see how we implemented on the CI side. So we are using the GitLab CI. So as we rely on masking, we get the schema, and then we are using a small bash script in order like to make our commit, our merge request for updating the schema. If we have nothing to update, no merge request. Otherwise, we'll have our update, so it runs nightly, and every morning we check like the status of the MR. If the CI is okay, we merge it, and so nothing to change. If we saw some fail in the CI build, we check if we can fix it by, for example, the schema change, and now the generation of the query had changed a bit, naming, stuff like this. So if we can fix it, we fix it. And if we can't, we sync with the backend team to say, okay, the build broke our application. What will be the real change of it, or is there an error, stuff like this. So far, that's the best way we found to automate the schema update. And for multiple flavor, if you have like some staging, production, white label stuff, so multiple flavor, you might have some multiple schema to maintain. This will lead like to multiple updates and potentially more maintenance on your side, so it might be painful to maintain. And for the, I said like any stuff about the community around Apollo is amazing. Kotlin is an open source project. Apollo Kotlin is an open source project. Maintainers are very active and very helpful. So if you have a question or an issue, go and ask on their on the Kotlin Slack or on the repository. They are gold people. And hopefully the Apollo 4 is in beta, I think, and it will have a great feature, especially a plugin dedicated to Android Studio. So it's going to be a nice one. So a bit of conclusion for the takeaways. Why it was a right move for us. Apollo Kotlin, based integration with our code base, coroutine and flow support, strong typing, and definitely a strong contract with our API. Combine query and the Apollo community and the Apollo maintainers when we have an issue. And the things to watch, like always collaborate, speak with your backend team when you spot an issue. Error handling is not the best thing so far. Subscription aren't really easy and reliable to work with. And Apollo AppSync support sometimes it's a bit glitchy. So if you want like to take a look at some documentation, GraphQL, that's the job if you want like a wide knowledge on it. Apollo Kotlin, Apollo repository. They release also nice videos for the Apollo GraphQL Summit. And if you have some AppSync backend, here are the documentation. So thank you very much. I'm a bit late, sorry, but thank you so much. And have fun with GraphQL.